Namaskar. Would like to welcome you all
चिंता टॉपिक था
of Independent Research Ethics Society at 2226 milestone. Thank you very much for joining. Today we are celebrating Biofuel or Biodiesel Day, National Biodiesel Day. It is called in some state, but for our concept, we are celebrating every day for the betterment of society, for the betterment of every aspect of our life, especially with related to health. So I really congratulate Dr. Sekat to take this concept. Thank you very much. And I would like to request Professor Vishnu Prasad Sharma sir for his kind blessings. Adani Vishnu Prasad Sharma sir.
नमस्कार हरिओम I Professor Dr. Vishnu Prasad Sharma welcome all of you to this AYUSH Samriddhi International Webinar Series on Biodiesel Future for Green World. In this webinar, we have eminent speaker. I want to welcome Dr. Soikat Kumar Basu from Alberta, Canada. Namaskar, sir, and welcome you to this Ayush Samriddhi webinar. Once again, I welcome all the eminent speakers, distinguished guests, ladies and gentlemen, to this Ayush Samriddhi International Webinar Series on Biodiesel Future for Green World. सबको स्वागत करते हूँ नमस्कार ओवर टू पवन जी आपका वॉइस नहीं आ रहा है
Thank you very much, sir. Thank you very much. Now I would like to request Dr. Sekat Kumar Basu for his presentation on biodiesel.
Thank you, Sharma ji. Thank you, Sharma ji. Both thanks to both of you for inviting me once again to this platform. I'd like to say that biodiesel is a renewable biofuel. It's a form of a diesel fuel. And why it is called biodiesel? Because it is from biological sources such as vegetable oils, animal fats, or recycled grease consisting of long-chain fatty acid esters. It is typically made from fats. And why it has become increasingly popular to this day and is called biodiesel or a biodiesel from plant sources is because this is now derived from the plant sources. The roots of biodiesel as a fuel source can be traced back long time back when Patrick and Duffy, the two scientists who first conducted trans-esterification of vegetable oil in 1853. And these very chemical, organic chemistry achievement that they made later transformed into this diesel engine initially designed for mineral oil, successfully to run on peanut oil during the 1900s Paris Exposition. The landmark event highlights the potential of vegetable oil as an alternative fuel source. None at that particular point of time thought about that how important it would become down the line because of environmental pollution and stresses associated and related to the fossil fuels. We have been looking for a long time for alternative fuel sources, and out of extensive research, replace development for a long period of time, biofuel has found a position of its own. It is an area of extensive research in many countries, and there has been lots of development made in various areas associated with this. The interest in using vegetable oil as fuels resurfaced periodically during resource-restrained periods such as the World War I and II. But challenges of using such a high viscosity and resultant engine deposits were significant hurdles. So it was not an easy thing to make the vegetable oil popular as a source of fuel and has gone through significant way. The physical and chemical properties of biofuel vary according to the source from where it has been made. The US National Biodiesel Board defines biodiesel as monoalkyl ester. From the chemical point, it is important to mention that it is characterized by a high boiling point and flash point. Than petrodiesel, biodiesel is slightly miscible with water and has distinct lubricating properties. Its calorific value is approximately 9% lower than that of standard diesel, impacting fuel efficiency. The primary application of biodiesel to this day is in transport. There have been efforts to make it in a drop-in biofuel, meaning a compatible with existing diesel engines and distribution infrastructure. Extensive research has been made on these areas. However, it is usually blended with petrodiesel, typically to less than 10%, since most engines cannot run on pure biodiesel without modification, particularly because of its high esterification and its sticky, high viscosity nature. Special engine needs to be derived. The blend percent of biodiesel is indicated by a term scientifically known as B factor. A B100 represents pure biodiesel, whereas a blends like B20 means it contains 20% of biodiesel. These blends offer compromise between environmental benefits of biodiesel and performance characteristics of the diesel fuel. The environmental, why it is so important is due to the fact that the environmental impact of biodiesel is complex and varies based on the various feedstock types, land use changes, and production methods. While it can potentially reduce the greenhouse gas emissions compared to fossil fuel or conventional fossil fuel sources, there are also concerns about biofuels increasingly with respect to land use or the changes in the pattern of land use, the rapid rate of deforestation, and the food versus fuel debate. Now, why are these points so important? In the sense that there was a time when this biodiesel was an extreme, not so popular, but first in the Americas, particularly in South America, Brazil has been very efficient in transforming hydrogen oil or biodiesel oil from sugarcane. It was a country that was using this for a considerably long period of time, and it was a global model. But not many countries had adopted these and integrated them into their system until then, when USA started going massively for biodiesel promotion, with the idea was that we will have greener fuels which will be environmentally sustainable and also reduce the amount of greenhouse gases in the environment. But the increasing pressure in which the biodiesel cultivation was initiated in USA, there were important concerns that many farmers were jeopardizing our national food security, in the sense that they were growing an industrial crop for industrial purpose like the biodiesel, rather than doing the requisite quota of food crops that were essential for the sustenance and protection of food diversity as well as food security of United States. More and more farmers started moving from conventional food based agricultural production to this industrial production where they're increasingly producing biofuel. Now the challenge was there was not so many industries available at that particular point of time who could utilize and convert the plant sources back into biodiesel, which could be used by various vehicles. But at the same time, there were increasing shortage of food that was noted, and then steps were taken by the US Congress to reduce and limit the cultivation and production of biodiesel. So this is associated with a challenge. The other part is that whenever in some other developing countries where biofuel has been implemented to start as a constant green fuel, or they were more focused on producing biofuel, significant conversion of land started. People were destroying forest, opening up land, completely annihilating the biodiversity of that region, and they started growing various of these biodiesel products because if the common factories were able to produce biodiesel for them, they were trying to sell it to other countries rather than for using for them. So all these new challenges we never thought that could come up with the biodiesel production came up. In spite of being a green fuel and sustainable environmentally, it resulted in many cases in destruction of the natural ecosystems by ravaging forest, opening up fields, killing wildlife, removing and eradicating them at a very fast rate, and producing many of these destructive changes that were detrimental for the environment. The same environment that we have been trying to protect was depreciated and degraded because of this overuse of biofuel production. Now, little bit on the application, why biodiesel has become popular and why it is so significant. It is that biodiesel can be blended, particularly in the petroleum diesel, at any concentration in most injection pump diesel engines. Now, extreme high pressure, such as 29,000 pressure per square inch, common rail engines have strict factory limits of B5 or B20, which means that they could not have biodiesel at the level of more than between 5 to 20%, depending on the manufacturer. Biodiesel has different solvent properties from petrodiesel and will degrade natural rubber gaskets and hoses in the vehicles. Although these tend to wear out naturally and most likely will have already been replaced with FKM, which is non-reactive to biodiesel, but these increases expansion or expenses of the engine designs. So biodiesel has been known to break down deposits of residue in the fuel lines where petrodiesel has been used. As a result, fuel filters may become being clogged with particulates if a quick transition to pure biodiesel is made. Therefore, it was recommended that to change the fuel filters on engines and heaters shortly after switching to a biodiesel blend. So there were challenges, particularly from the technological point and also from the cost effectiveness by uh, changing and modification of this use. Since the passage of Energy Policy Act of 2005 in USA, biodiesel has been increasingly used. Even in United Kingdom, or the renewable transport fuel obligation obliges suppliers to include at least 5% renewable fuel in all transportable fuels sold in UK by 2010. For road diesel, this effectively means 5% or 5% of mixture of biodiesel into the conventional fuel. What kind of vehicles are capable of utilizing this? In very short, without going into too much detail, in 2005, Chrysler released the Jeep Liberty CRD diesels from the Europe factory into the European market with 5% diesel blend. In 2007, Daimler Chrysler indicated its intention to increase warranty coverage to 20% biofuel blends. The Volkswagen Group, one of the most famous international group from Germany, has released a statement indicating that several of its vehicles are now compatible with B5 and B100 made from rapeseed oil, which is kind of mustard, and compatible with the EN 114 214 standard. Mercedes-Benz does not allow diesel fuels containing greater than 5% biodiesel due to concerns about production shortcomings. Any damages caused by use of such non-approved fuels will not be covered by their Mercedes-Benz limited warranty. So one of these limitations that Mercedes-Benz has come up is saying that they do not have this system right now within their system. In 2005, 2007, McDonald's in UK announced it would start producing biodiesel from Westfall, which still they have continued. And in 2014, Chevy Cruise Clean Turbo Diesel direct from the factory were rated up to B20, means 20% mixture in the biodiesel and 80% regular diesel. These combination was used. Are these restricted only to vehicles or the surface transport or road transport? No. This is also associated with railway engines and locomotives too. British train operating company Virgin Trains, West Coast, claimed to have run the UK's first biodiesel train. The British Royal Train around September 2007 completed its first ever journey that ran on 100% biodiesel fuel supplied by the Green Fuels Limited. This was the first example of in the entire world where the railways ran entirely on biodiesel. Prince Charles and Green Fuels Manufacturing Director James Higgett was the first passenger on this train. Since 2007, the Royal Train has operated successively on B100 or 100% biodiesel. Similarly, state-owned short line railroad in Eastern Washington in US ran a test on a 25% biodiesel and 75% petrodiesel blend or a mix during the summer of 2008, and it has ran successfully. The train was powered by diesel in part made from canola. Canola is a variety of the same mustard that is grown in North America, particularly in Canada and North America and Canada and United States. It originated from Canada, and it has a much better health-related aspects of the oil produced in the seeds. And this specific oil is made by a particular species, Brassica nape or Brassica napus, and this is called canola. In 207, Disneyland began running their park trains on B98, which means almost 98% biodiesel. The program was discontinued however, in 2008 due to shortage issues. The historic Mount Washington Cog Railway also started using biodiesel in their locomotives since 2007. In 2007, the Grand Canyon Railway also started using a biodiesel as their engine oil. And on 2014, the then Indian Railway Minister D.V. Sadananda Gowda announced in railway budget that 5% biodiesel will be used in Indian Railways diesel engine. Till now, this has not been very successfully implemented in the Indian railway system, but nonetheless, it has been becoming over and out an important source of oil and is being replaced and being utilized. It is also used in oil spill with 80 to 90% of oil spill cost invested in shoreline cleanup. There is a stretch for more efficient and cost-effective methods to extract oil spills from the shorelines, and biodiesel had displayed its capacity on the source of the fatty acids and been extensively replaced. They are also nowadays used in generators. In 2001, UC Riverside installed a 6 megawatt backup power system that is entirely fueled by biodiesel. So since then, power supply by biodiesels have been increasing, particularly with respect to fuel efficiency. The power output of biodiesel depends on its blend quality and load conditions under which the fuel is operated or burnt. The thermal efficiency of, for example, 100% biodiesel is compared to B20 vary according to different energy content of various kinds of blends. One study found that the brake thermal efficiency of B40 was superior to even traditional petroleum compound parts. Combustion-related information, fuel systems on some modern diesel engines were not designed to accommodate biodiesel, while many heavy-duty engines are able to run with biodiesel blends up to 20. Since 2000, several companies, whether railways, ships, and as well as our straight line vehicles that are being manufactured are increasingly being created with engines that can process our biodiesel. But these biodiesel engines are a bit more expensive, and hence it has not become so extensively popular right now with the customers around the world, because the maintenance cost is higher and the biodiesel also cost higher. In spite of the fact, even if the blends are used, it is still more expensive. It is definitely good for the environment, but affordability is one such important part that needs to be dealt with. Are there any bad emissions that also happen from biodiesel? This is a very interesting question. Emissions are inherent to the combustion of diesel fuels that are regulatory to US Environmental Protection Agency. As these emissions are a byproduct of any combustion process, in order to ensure externally performs well of the compliance of the fuel system, it must be capable of controlling the combustion of fuels. There are a number of new technologies that are replacing and making engines more combustion efficient, making biodiesel use much more technically feasible and trying to make it materially feasible too. Material compatibility is another important thing, and why is because biodiesel used in conventional other engines in the olden times have been corroding the engines, but now it has been found that various grades of plastics such as high density polyethylene HDPE is compatible with polyvinyl chloride is slowly degraded with biodiesel. Polystyrene is dissolved on contact with biodiesel. So any kind of polystyrene plastic could not be used, but high density polyethylene has become popular. Biodiesel has an effect on copper-based materials and brass, and it also affects zinc, tin, lead, and cast iron. So stainless steels in the grade of 316 and 300 chrome and aluminium are found to be unaffected. And the other good part is rubber. Biodiesel also affects different types of natural rubber found in some older engine components. Studies have thenceforth showed that fluorinated elastomers, which are commonly known as or more popularly called FKM, cured with peroxide and base metal oxides, can be degraded when biodiesel loses its stability caused by oxidation. As you could see that all these areas definitely are sophistication, and biofuel is definitely becoming popular. However, there is a cost involved in this. So there is a compatibility and fight going on right now that how to make biodiesel more affordable and more engine stable, as well as less damaging to the conventional materials and the structures that we use for engine, so that if we do not have to use very high quality steel grade and other part, then the cost of engine production also goes up while they are using biofuel. So cheaper alternatives right now are being worked out, but it will still take some time before it is made available to the market. We were only talking about higher plants like, from sugarcane and other part where biodiesel is produced. Recently, it has been mentioned that attempts have been made from 1978 to 1996 to produce algal biodiesel, and now it has become quite successful. It has been shown that UNH biodiesel group offer estimates for the relative replacement of all vehicular fuel with biodiesel now produced by utilizing algae that have a natural oil content greater than 50%. Now, this is a very important discovery. Extensive research is continuing not only in US but also in the European Union to figure out that if we could grow algae as a part of a rich source for the fuel production, then the cost of production could be laid down, particularly with agriculture, and actually the biodiesel cost could be go down. But it will still take some time because the production of algae to harvest oil for biodiesel has not yet been undertaken on a very large and successful commercial scale. But feasibility studies have been conducted to arrive on the above yield estimate, suggesting that unlike crop-based biofuels, algal biofuel does not entail a decrease in food production. So because it is not utilizing a large number of land, because it is not involving forest destruction and etc., fossil, particularly algal biofuel, has a huge potentiality of becoming the fuel of the choice in the near future. But research investments are right now going on. Various different plants like Pangomia, Jatropha, and other kinds of sewage-based materials, even fungi, are now being extensively used, from coffee grounds to some byproducts of waste out coffee materials. Biofuel production has been being tried out. So various scientists, safflower oils and other sunflower oil has been modified and been attempted to convert them into biodiesel. So extensive research is going on. But still, to make it affordable, make it more efficient, and make engines affordable for public to use 100% biodiesel is still a challenge, but work is on. With this, I have great hope for biodiesel in the future. As the cost goes down, it will definitely become more popular for others to use. And while we are still not being able to use extensively biodiesel, an incorporation of biodiesel with petrodiesel mixture could be an important aspect that we could look for. So thank you very much for this opportunity provided, Dr. Sharma. It has been a pleasure to be on your platform.
Thank you, Dr. Sakat. Thank you very much. With your kind permission, I would like to share a presentation, if you permit me, for 10 minutes.
Sure, sure.
Dr. Sakat.
Please go ahead. Please go ahead. Thank you, Sharma.
What is biodiesel? It is renewable and natural domestic fuel extracted from animal fats or vegetable oils, mostly from soybean, rapeseed, jatropha, palm oil, from any one of these. Imami had started one biodiesel unit, but it was not feasible before 20 years. So they converted into Imami Healthy Tasty Oil industry in Haldia, but that actually biodiesel plant. Biodiesel is a general name given for methyl esters obtained from organic feedstock. Anything. What are the benefits? Biodegradable, renewable, non-toxic, extremely low emission of greenhouse gases in comparison to fossil fuels, increase in trade balance, Indian perspective, due to lesser dependence on foreign resources, promoting environmental protection and energy security in the country, meeting climate change commitments, growing variety of crops increases biodiversity, promoting renewable energy sources, generating rural employment opportunity, etc., etc. Various opportunities are there, benefits are there, and scopes are there. So biodiesel generally vegetable oil or animal fat से and an alcohol through a trans-esterification reaction, stages of trans-esterification, treatment of raw material, alcohol catalyst mixing, chemical reaction, separation of reaction products, and purification of reaction products. So this is in very simple graphics. We can easily understand that these molecules are esterified, trans-esterified. So fatty acid, alcohol, glycerin, all combination is generally called biodiesel fuel. These are the stages of that: oil, esterification of oil, then separation 2, and then complete ester will be there, and that will be called biofuel. So canola oil, rapeseed oil, corn oil, palm oil, algae oil, other plant oils, various plant oils, or used cooking oils. This is also one in catering services or in halwai shops, sweet shops. Used means ultimately extremely used cooking oil is also raw material for this. So alkali catalyst, KOH, potassium hydroxide, when it makes it with these oils, plus methanol, and then after eating, fatty acid, methyl ester, and glycerol. These are the product. Fatty acid and methyl esters are biodiesel. This is biodiesel production process. Jatropha, suited raw material. So generally plants are able to produce seed between 1 and 5 years, depending on soil fertility and rainfall, and continue to produce seeds for more than 20 years. रतनजोत भी इसका एक नाम है, लेकिन वो अल्टीमेटली ये माना जाता है कि 20 साल तक फल देती है. 1.5 से 2000 केजी सीड पर हेक्टेयर इसमें कल्टीवेट कर सकते हैं. यील्ड इसकी इतनी है. सीड्स कंटेन एवरेज 34.4% ऑयल बाय वेट, और उसको हम बायोडीजल फ्यूल में कन्वर्ट कर सकते हैं. Yield of biodiesel per hectare for Jatropha is more than 4 times as much fuel per hectare as soybean and up to 10 times that of corn. माने Jatropha is the best suitable plant for biodiesel. सोयाबीन से 4 गुना और कॉर्न से 10 गुना इसका यील्ड मिलता है. ये ब्लेंडिंग भी इसमें, जैसा हमारे डॉक्टर शैकत बसु ने बड़ा डिटेल में बताया, B2, B5, B10, B20, B100, ये पूरा एक बार आपका ब्लेंडिंग में चलता है. और जो पूरा का पूरा है वो तो B100 है, 100%. कन्वेंशनल यूज बता ही दिया कि मिक्स करने के बाद जो पुराने इंजन है उनको मॉडिफिकेशन करना पड़ेगा, लेकिन नए इंजनों में ये यूज हो सकता है. अनकन्वेंशनल यूज, जो ट्रैफिक की तो बात कर ही ली. हाइड्रोजन फ्यूल सेल में भी इसका यूज होता है, माइक्रो रिएक्टर्स में, टू प्रोड्यूस हाइड्रोजन स्ट्रीम फॉर HFC. क्लीनिंग अप ऑयल स्पिल्स, साइटोसोल है वो यूज होता है क्लीन और डिजोल्व क्रूड ऑयल स्पिल्स को. जनरेटिंग इलेक्ट्रिसिटी, बैकअप जनरेटर यूजिंग B100. होम हीटिंग, B20 reduces emission of sulfur dioxide and trioxide emissions from boilers and used to heat home. तो ये बायोलॉजिकल साइकिल है. सूरज से चली, ऑयल क्रीप ली, सीड लिया, क्रूड वेजिटेबल ऑयल बना, रिफाइनिंग किया, रिफाइंड बना, एल्कोहल मिला के उसमें ट्रांस एस्टरिफिकेशन हुआ, एल्कली और एल्कोहल मिला के और बायोडीजल मिल गया आपके व्हीकल्स में, उसमें ग्लिसरॉल भी बना। डिसएडवांटेज, अब मैं यदि इसके डिसएडवांटेज की बात करूं, स्लाइटली हायर फ्यूल कंजम्पशन ड्यू टू द लोअर कैलोरीफिक वैल्यू। इसकी जो कैलोरीफिक वैल्यू है थोड़ी कम होती है नॉर्मल डीजल पेट्रोल से, तो इसकी फ्यूल कंजम्पशन थोड़ा ज्यादा रहता है। स्लाइटली हायर नाइट्रस ऑक्साइड इमिशन देन डीजल फ्यूल। वहां कार्बन के ज्यादा इमिशन है, इसमें नाइट्रोजन का ज्यादा इमिशन है। नाइट्रस ऑक्साइड इसमें थोड़ी स्लाइटली ज्यादा बनती है। हायर फ्रीजिंग पॉइंट देन डीजल फ्यूल, डीजल से इसका हायर फ्रीजिंग पॉइंट है। ये इनकी कन्वीनियंट हो सकता है कि वो कोल्ड क्लाइमेट में जाए और मालूम पड़े कि वो पूरा ही जम गया तो मामला खत्म हो गया। इट इज लेस स्टेबल देन डीजल, सो लॉन्ग टर्म स्टोरेज इसकी थोड़ी प्रॉब्लम है और नॉट रिकमेंडेड है। कॉन्स्टेंस, एनवायरमेंटल कॉन्स्टेंस इसके साथ है, हम जानते हैं। ट्रेड कॉन्स्टेंस, फर्स्ट जनरेशन बायोफ्यूल आर रेयरली इकोनॉमिकली कॉम्पिटिटिव। पेट्रोलियम फ्यूल मिलते हैं आराम से, धारा निकलती है और इसमें कल्टीवेशन से लेके इतनी प्रोसेस करनी पड़ती है कि इसकी कॉस्ट बढ़ जाती है। फूड सिक्योरिटी कॉन्स्टेंट्स, बायोफ्यूल फीड स्टॉक प्रोडक्शन कॉम्पिटिट्स विद द फूड फाइबर एंड टिम्बर फॉर लैंड वाटर एंड फर्टिलाइजर्स। इतनी सारे पॉइंट्स हैं जो फूड सिक्योरिटी में इसके कंपटीशन में खड़े हैं। जैसा अभी सकत जी ने बताया कि लोग बाग वो गेहूं छोड़ के और यही उगाने लगे तो मालूम पड़ा कि वहां गेहूं का अकाल पड़ गया। अच्छा, दिस कॉम्पिटिशन कुड अफेक्ट फूड सिक्योरिटी। और जो फीड स्टॉक क्रॉप्स हैं, मक्का है, गन्ना है, तो ये इसलिए ग्लोबल फूड प्राइस वॉलेटिलिटी की इसकी शिकार रहती हैं, तो इसमें गौर से करना चाहिए। So the era of cheap oil has ended. It is essential for India to look for alternative renewable fuel options such as biofuels, biodiesel and bioethanol to provide energy security and environment protection. Thank you. Thank you all for listening. Thank you very much. पारुल जी कुछ बोलेंगे? मैडम पारुल जोशी जी। सभी को गुड नाइट, यूट्यूब के दर्शकों से भी गुड नाइट। कल फिर मिलते हैं 3 नए विषयों के साथ।